All right, let's have a look at question number 1. We're told Bjork Larson is trying to decide whether to use a new racing wax for his cross-country skis. He decides the wax will be worth the price if he can average less than 55 seconds on a course that he knows well. So he plans to test the wax by racing the course 8 times. And here's the 8 times. Or, yeah, this time it took him to race this course 8 times. Should he buy the wax? And we want to make our conclusions at a 5% level of significance. All right, when we're looking at a question like this, we got to try and decide what are we talking about here, because we're generally going to be talking about averages or we're talking about proportions. Now, in this case, we're already told up here, keyword, we want to know, can he race this course on average less than 55 seconds? And really, ultimately, what we want to know is whether or not the average of these 8 races that he's done, whether this average is significantly less than this 55 that he's kind of set as the standard by which he's going to judge the performance of this wax. Now, we're testing a population mean. We have a choice between a T or a Z, and we'd only use the Z if our sample size is over 60 or if we knew the population standard deviation, which we are not told. So that means we're dealing with a small sample size. We're doing a test on a population mean, and the test is going to be the one sample t-test as I've typed in right here. Now, my null hypothesis is that the average time it takes him to race this course is 55 seconds. What we really want to know is, does it take him less than 55 seconds? So if it turns out to be this one up here, then the time it takes him is not low enough. And in this case, I would conclude my wax is no good. It's not worth the price. If he can race it in significantly less than 55 seconds, then the wax is worth the price and he should go buy it. Now, down here I've put in my level of alpha. We were asked up here to run this test at an alpha 0.05. Anytime we do these tests of hypotheses, we state the hypotheses. We then generally are asked to calculate a test statistic. To do that, you need some summary information. And I've already gone to Minitab and got the mean and the standard deviation. And Minitab also, by the way, will give you the standard error of the mean, which is good, as we're going to see here shortly. Right here, I've calculated my test statistic. It's a t this time. We are comparing the mean of the sample, which, by the way, is only 55.1, so that's not looking too good for wax. 53.1, sorry, minus the mean that's in our statement of claim, divided by standard deviation of the sample, no pretense here about knowing sigma, divided by square root of sample size. All right, and by the way, that's 7.03 divided by square root of n. If you do that on your calculator, you're going to get to 2.48, which Minitab automatically gives you in your summary stats. So we do the math, we get a test statistic of a minus 0.76. Now, really, and I've already got it done here, but I'll show you how to do this in Minitab. You don't have to, though. If I really want to illustrate this, showing the area under the curve, notice this thing says t-distribution with 7 degrees of freedom. I give it the test statistic, which in this case is the t, minus 0.706, and I'm looking for the area to the left. How come? Because that's what my alternate hypothesis says. I'm looking for the area to the left. Now, I've already run the test in Minitab, and I'm going to show you how to do that here now. I have told Minitab I want to use the one sample t. Here's the hypothesized mean, and I wanted to know, was it less than 55? It cranks me out my test statistic, which is right here, and gives me a p-value, which is not exactly the same as what I got in that plot, but Minitab's rounding to 3 places after the decimal here, so I'm not quite sure what's going on there. Oh, I know what's going on. The test statistic right here is rounded off, whereas right here, I know yes, I know. I typed in 0.76. but 0.76 is a rounded figure. So we're not going to worry about that too much. Who cares? Now, let's go to Minitab and see how we would do this. So we have calculated, and by the way, I went into my basic statistics and I got some basic statistics. You can turn off these if you want. Yep, there's some of the data that I need to calculate the test statistic. And if I actually wanted to illustrate the p-value, I go into probability distribution plot, pick the t-distribution. Degrees of freedom on the t is always 1 minus your sample size. We had 8 races. We give it the test statistic, which was a negative 0.76, and I want the area in the left tail. And that's what I get, 0.360. All right, now running the test in Minitab, because that's ultimately what this is all about. Basic statistics, in the last set of notes we talked about, or last assignment we talked about one sample Z. Now we're looking at one sample T. We give it the raw data, perform the test of hypothesis, compare the population mean to 55 versus I want to know, is it less than 55? Other thing we should do, because it's going to pop up when we talk about assumptions, when you use the t-distribution, the assumption is that your data are normally distributed. And that's showing right here, and I'll have it included in the Word document as well. Now, the distribution of this box plot, this looks very symmetric to me. No issues. If in doubt, run a Ryan-Joyner test, but really there's not a problem with this. They're absolutely symmetric. Now, here's the results of my one sample T. Always check up here to make sure that you ran the thing you intended to run. It should say less than, which it does, my test statistic, and my p-value. All right, coming back into my Word file here now. The question now that I have to ask myself is my p-value less than or possibly equal to my alpha? So here's my p at 0.235. Is that smaller than 0.05? No. And anytime the answer is no, I fail to reject my null hypothesis. What am I concluding? I'm concluding that my mean race time is not significantly less than 55 seconds, and Buddy shouldn't buy the wax. It's not worth the price. All right, the other thing we were asked to do in this assignment was to, or in this question, was to calculate a confidence interval on the mean. And we're calculating the confidence interval. This looks very similar to what we did in assignment number 5. The difference being here that we're using the t-distribution rather than the z. And of course, we're just using the sample standard deviation. So I've got my sample mean, sample standard deviation, my sample size. These numbers are all up here, or I can get them from my summary stats. I plug all this in and I get my answer, but the question is now, how did I get this t? I want a 95% confidence interval, which means that the area in the center of the curve is going to be 0.95, and collectively the area in the tails is 0.05 over the two tail areas. Each tail area is only 0.25. So right here I've said, okay, I'm looking for a t that cuts me off an area of 0.025, and when we go into the t-distribution, we have to go in for a specific number of degrees of freedom, and in this case it's 7. So I've got, hang on now, in D2L I've posted the t-distribution table for you, and here it is. And I want, this thing here shows me areas in the right tail. It doesn't matter if it's right or left. But this area here, I want it to be 0.025. I come into this table. Here in blue are the available areas, 0.025. I come down to 7 degrees of freedom. And here's the t-value I'm using. And I think in the calculation I use 2.365 if you round that off to 3 places after the decimal, and that is the value that your textbook also gives you in the table that it provides for you. Alright, now come back here. So what can I say? I'm 95% confident that the true average time it takes Bjorn, whatever his name is, to run this race with this wax falls somewhere between 47.22 to almost 59 seconds. Now, if I was answering this question from the point of view of the confidence interval, I'm going to come to the same conclusion as the test of hypothesis. The test of hypothesis said my p-value is smaller than 0.05. I failed to reject, and by failing to reject, really what I'm saying is that there's not enough evidence to say he can race this course in less than an average of 55 seconds. When I look at my confidence interval, all right, only way that he can race it in less than 55 seconds is if all the numbers in this interval are smaller than 55. Now the bottom one is, but the top one isn't. So what does that tell me? It tells me exactly the same thing as the test of hypothesis does, that he cannot race this with this wax, cannot race this course with that wax on his skis in an average of less than 55 seconds. And I think I've just pretty well covered question number 1. So, end of story.